Joel Rela, the insurance adjusters based in the UK, just put out that nice little summary of all the types of damages that wind turbines suffer. It was quite fascinating to read through that. I didn't realize, gearboxes and some of the other issues are so massive right now.
Yeah, man, it's really eye-opening to read that report. Martin Dobson, their technical director over there at Rela, puts up. They're always putting out great stuff. But the really interesting one, if you haven't looked at it, it's on the WinPower Lab LinkedIn channel. But the lightning damages, right? I mean, we're always talking about lightning. So WeatherGuard, Lightning Tech, of course, Lightning Company, and Alan, the expertise that you bring to that space. When you read through this little article that they put out, this little presentation, you see how many damages are related to lightning. It'll blow your mind.
It's $100 million. I would just quickly add it up. Back of the envelope is $100 million. Like, that's a lot of insurance adjustment to be done, and a lot of it's preventable. It's crazy. I know we get requests all the time at WeatherGuard here to upgrade the lightning protection systems, and most wind turbines we can upgrade relatively inexpensively and quickly. So this $100 million of insurance money is being spread around should be cut in half easily at this point. And you and I, Joel, we have conversations all the time about how we can inform the industry on what can be done, and we finally decided to put together a webinar.
Yeah, absolutely. So here, coming up in August, you guys can dial on. We'll, of course, share it here on the podcast platform and through all of our other email platforms as well. But we're going to have Morten Hanberg, the Chief Blade Specialist from WinPower Lab, and of course, Alan Hall here talking about lightning. So Alan bring the physics side and all of his knowledge, and Morten share the blade side. And we're going to put a webinar together, some live Q&A, and be able to engage directly with the audience.
Yeah, so keep your eyes open for that. Morten is going to add a tremendous amount. So if you're not sure what kind of damage you're seeing on your blade or why you're seeing some weird things happen on your blade, Morten will know. And it's a great opportunity to pick Morten's brains or to pick my brain about lightning. And it's all going to be on LinkedIn.
Yeah, and to be honest with you, more importantly, to the listeners out there, we're going to talk about why, how, what the damages are, how it relates to you commercially and economically within your wind farms. But the biggest thing is, how can you prevent it? How can we slow down? How can we lower the costs of damages? And can we monitor for them? Can we retrofit for them? What can we do to save you some bottom line?
It's going to be good. So keep your eyes open for that. This week in the news, a lot of things are happening around the world. The Revolution Wind 2 project has been rejected by Rhode Island. Orsted and Eversource are trying to regroup there. New York high energy prices, you're just going to see about a 10% price increase coming up in New York, and what's driving that. And then Vattenfall over in Sweden is stopping one of their projects that was going to feed the UK with clean renewable energy. So not so good on the offshore front.
So after talking about the offshore wind in the UK, we're going to jump back over to the States to talk about Fervo Geothermal and the breakthrough that they recently had in developing a 3.5 megawatt geothermal power plant here in the States, and what we think that could do if we can scale it up, what that would mean for the energy transition here. Also, GE Vernova put out a little bit of some news, kind of what the things they're doing to increase on quality. So daily meetings and some other cool stuff they're taking on internally. And we also asked Vic Abate to join the show. But we're also going to talk about GE in regards to that, delaying some deliveries to a project in Wyoming. And we kind of say our opinions on why we think that's happening and why we both believe it's actually a good thing. And then lastly, the wind farm of the week, Flat Ridge 1 upgrade for BP Energy. So we'll chat about that as well.
I'm Alan Hall, president of WeatherGuard Lightning Tech, and I'm here with the vice president of North American sales for WinPower Lab, Joel Saxum. Rosemary is on holiday, and this is your Uptime Wind Energy Podcast. Rhode Island Energy, the largest utility in Rhode Island, has decided not to proceed with a long-term power purchase agreement with Orsted and Eversource for the Revolution Wind 2 offshore wind farm. This decision was attributed to high interest rates, increased capital costs, supply chain expenses and uncertainty around the federal tax credits, making the proposed contract cost too expensive for customers. The proposal didn't meet the requirements of the Affordable Clean Energy Securities Act, which is a Rhode Island initiative. So what they're saying is the PPA price is too high, and Orsted and Eversource are providing realistic numbers to Rhode Island. They just don't like them, Joel.
Yeah. So, I mean, we've been talking about this for a while now. Like some of these PPAs are starting to dissolve. They're paying penalties along that East Coast. The developers are. But I guess if you're, I guess the one positive thing here is if it small enough, Rhode Island doesn't take up that much shore. So if they don't like Rhode Island, they can go to Connecticut, go to Massachusetts, or go to New York. You could stretch her out and go to New Hampshire or Maine or something like that. But that will raise costs for the developers as well, because they'll be running some high voltage lines further and further in the water. It's frustrating to see now. Of course, like I said, as we talk about, but that there's just nothing you can do about it, right? At this stage, it's the capital costs, it's the financing costs that are just going through the roof. The supply chain. I haven't heard that much of the actual turbines getting more expensive, to be honest with you. But it's the financing behind it, right? If you go from when these things were planned and auctioned off at, the interest rates were down at 3 and 3.5%, and now they're up around 7. That's 3.5% profitability in a project. If it was completely 100% financed, would go away. I mean, that's your on some of these large utility scale things. That's damn near your margin, which is frustrating to see, but it's the truth.
I've heard more recently operators saying they wanted between 6 and 8% return on investment, which would be normal. I think that's totally reasonable.
Say 6 to 8% return on investment is what you want, and now you've just lost 3.5% of that. Well, now you're down to 2.5 to, that's just not, that's skin of the teeth margins. And it's not, you have one error or one bad thing happen, one cable break that doesn't get insured or something like that. And now the project's, it's just too risky.
Well, and operators have investors, and they have to satisfy the investors. They have stock prices too. They got to watch both ends of their business. And yeah, this makes sense. I went back and did some research on the Revolution Wind efforts and looked at sort of early on, like 2018, 2019, when they're talking about what the PPA would be with the turbines being installed, the transmission lines, the substations, the whole thing, and transmission costs. And they were looking at PPA prices around in the $90 megawatt hour. So I think for this particular project, they have been around in the 90s, which is much higher than other numbers I had seen, which I've seen a lot of 75, 80s. I think we're talking about $100 megawatt hour numbers for this PPA after all the costs of interest rates and inflation.
Well, I mean, you're in Massachusetts, Alan. What do you guys pay for power? You're in the Northeast.
It's scary. It's like double what they pay in the Midwest.
Okay, so let's take a step to the side, I guess, and see like, hey, if Rhode Island doesn't want to take this, and then the next state over doesn't want to take the same PPA price, or someone eventually will, but we want something to be efficient. We don't want Orsted to sit there with this plan and all these things juggling and not have a PPA for offtake, because if you don't have offtake, you can't reach a final investment decision. So what are the answers? Are the answers a private offtake? Is there anybody that can take that much power privately? I don't think so. Not up in the Northeast there. Or is it some kind of crazy idea of an emergency subsidy from a state or a federal government to keep, to hit Biden's goals of the 30 by 30 for gigawatts for offshore wind? If the PPAs aren't in place, these wind farms will never reach a final investment decision, and they will never get built.
Just looking at some numbers online here real quick on Massachusetts electricity prices. Of course, there's different rates and it's sort of set by the state, but it's in the $75 megawatt hour number. Seems about right for the East Coast. Now, the thing about Revolution Wind 2 was it was expected to bring more than $2 billion in direct economic benefits to Rhode Island and create local jobs and all the port infrastructure stuff and the shipbuilding and all that was going to happen. $2 billion is a lot of money. It seems like Rhode Island really is the one that's going to get hurt here, not Orsted.
Yeah, and if I was Orsted / Eversource and Rhode Island rejected my PPA and basically put my project in jeopardy, well, then I wouldn't want to be giving them the benefits of it. I would switch to Connecticut or New York or whoever else accepts the PPA eventually. I would say, okay, all of my vessels, my port, my people are going to go over here. So Rhode Island might shoot themselves in the foot.
They totally can do that. I hopefully know what they're doing. There was when this proposal came in from Orsted and Eversource, that was the only bid for this Rhode Island project. Like, so they were the only one who bid on it, and Rhode Island rejected it. Now, where does Rhode Island as a state go? Right? If they have renewable energy goals, this is one way to meet them. It's not going to get any cheaper.
That state's not very big. You don't have a whole lot of places to put other clean energy resources or exploit any clean energy resources besides offshore wind.
So here's what they're going to do, right? Let's just spitball this for a minute. Rhode Island's going to kick the can down the road. And as we have seen, if they wait 2-3 years, the Wood Mackenzie report we talked about a couple of weeks ago said if you wait 2 or 3 years, it's going to be worse because there's going to be so much more demand for turbines and people and infrastructure costs, right? That your prices are going to go up. The best deal is actually happening today, even with the interest rates the way they are. You're better to put turbines in the water now than wait till 2025, 2028. That's a mistake, right? Rhode Island's not thinking long term here right now.
Yeah, the only saving grace would be if the interest rates drastically came down, and I don't see that happening. We just had a Fed rate, hike increase here just yesterday. So if that's the case, that could be that. I would think that that's the only thing they could be betting on, or they're playing with calling bluff on cards, right? To see if Orsted will come down if they get pinched. But that's a hell of a bet.
Hey, Uptime listeners. We know how difficult it is to keep track of the wind industry. That's why we read PES Wind magazine. PES Wind doesn't summarize the news. It digs into the tough issues. And PES Wind is written by the experts, so you can get the in-depth info you need. Check out the wind industry's leading trade publication, PES Wind, at peswind.com. Well, speaking of high energy prices, New Yorkers are going to face more than a 2x increase in their electricity and gas bills by 2025 due to some rate hikes by the state's public utility regulator. Next month, August, Con Ed will implement basically a 9% rate hike as part of a 3-year rate plan approved by the state's Public Service Commission. Now, holy smokes, Joel. Inflation's really hit a lot of homes pretty hard. 9% increase in your electricity costs or natural gas costs is a huge problem. And it's not going to get any less. In fact, they're going to be accelerating some of these rate increases over the next couple of years. New York has set up a unique system in the way they are going to be powered and their environmental goals that are raising electricity prices. So you think that on the East Coast here, you'd be getting some pushback from the public to have less expensive electricity prices. This is what Rhode Island's going through, right? Their customers, their public, wants stable prices. It has a trade-off. And it just seems like energy independence for these states is a big problem. I'm not sure, New York is such a big state with a lot of people, how that's going to play out for them because they've had an exodus of particularly businesses and wealthier citizens leaving that state over the last 2-3 years. This is going to accelerate it, I would think.
I mean, nobody wants to pay the taxes, right? That's the big thing. I mean, so you do have some more generation coming in, right? Of these offshore wind farms, once they, again, I say final investment decision, but once they get to that point and they start installing things in the water, they're going to get hooked up. There's going to be some that go to the New York grid here. So there's that power on the horizon there, but if that, no matter what, that PPA cost comes in at X amount, it can be built into, that's a pretty easy function to do, right? A pretty easy bit of math there. So in this article, it states the utility attributes a large part of the rate increase to rising property taxes, particularly City of New York property taxes. So in my mind, I'm thinking, okay, then Con Ed must have a lot of real estate holdings within the City of New York for the property tax increase to go up. So as the state of New York trying to do well by their citizens, wouldn't you maybe not hit the public utilities with the rate increase for property taxes?
Yeah, you would think so. We've been around New York about 20 years now, so we've sort of watched it next door. It's a stone's throw from our facility. New York is really broken into two pieces, sort of. New York City and everywhere else. And what happens in New York City drives the outcome in Buffalo. It just does. And that's a huge problem for the state, right? 'Cause it's a huge state, a lot of people spread all over the place, but yet New York City drives the economy, it drives the direction.
It's like Illinois, right? Chicago controls the whole state.
Cook County does everything, right? Exactly the same problem. Now, I want to relive a conversation you and I had at ACP in New Orleans, which was we predicted, both you and I predicted that some of these offshore projects are going to be shelved for a little bit, that there's a big concern about the PPA prices. And you and I spitballed at the time, you need to get the states competing with one another. That's how you're going to drive some of these costs down. You need to have state to state competition. And most recently, the state of Maine is becoming more active in offshore wind. In fact, they just passed a bill, I think yesterday, that is going to be pushing offshore wind, floating offshore wind. It looks like
3 gigawatts.
Yeah, that's a lot of energy. And if Maine plays their cards right, they're going to set up the infrastructure to do it, have less restrictions to do it. One of the constraining pieces was the labor. How are they going to deal with unions? There was a bill early on that was going to require union labor. The governor vetoed that part of it, or said that she wasn't going to sign it, and that went back and forth. It seems like now they're going to have defined labor rates that are going to be set by the union. So if you're a company that has non-union labor, the labor rate's going to be set by the union. So everybody's going to be playing on a level playing field. Once that hurdle is done, then Maine, which could generate 8 gigawatts probably if they really get going, that energy may not stay in Maine. Who's going to use all the energy in Maine? In fact, they're probably going to ship that south to New York, right? That's where it's going to go.
Well, we talked about the possibility of some of it going to Canada as well.
Sure.
But what it seems like right now, with all these PPA battles going on further down the coast, it's still in the Northeast, of course, but it almost seems like the states are barring together. It's like they're banding together instead of competing with another. They're locking arms. And if you've got Maine that comes in there and says, "Well, Maine doesn't really play with New York very well, right? They're not the same. They're not the same people. So they're going to do their own thing. They're going to go, you know what? Well, you guys don't want it. We'll welcome the jobs. We'll welcome the offshore wind, and you guys can come and play with us. And eventually that power will drip down into New York, anyways. So yeah, it almost sounds like talking union. It sounds like the states in the Northeast are banding together, almost like a union, kind of against the developers, to control these PPA prices. And if you get this, we go back one, right? If we go back to that same Revolution 2 wind farm, if everybody denies Orsted and Eversource a PPA, they have no choice but to either cancel the project and lose everything they've invested in it so far, which would be just a catastrophic blow to the offshore wind industry, or lower their PPA price and take it in the pants. And I don't know if they can do that because the financing behind them might not let them. So there's I guess what we would, the old Mexican standoff there to figure out where this is going to go. It's I hope that they've got quite the battle going on.
Right, and they've done it to themselves. The states have done it, set their own environmental standards, are looking to get to certain energy goals, and New York's essentially going to be electrified. That's where they want to go there. When they set those goals and they make that push, and that's great. When the costs start rolling in, they get scared. You knew that was going to happen, right? It's not going to be easy to make a transition out of natural gas into electricity. That's going to be an expensive transition. You have to know that when you make those goals. And now that the reality has hit them, they're panicking and doing nothing. Like, if it was serious enough 5 years ago to put renewable energy goals in to help the environment, the whole thing, great. But now that the industry has met your requirements, it is now bringing forth the technology to make some of these things possible. Now you don't want to do it. No, you just can't have that. And I think the industry is going to push back hard.
The industry isn't saying hi; it's kicking the door in. It's like, we're here. We're ready to put steel in the ground and run cables. Like, where are you at? Let's go.
And the states are getting weak-kneed, unfortunately. Yeah, it's a huge problem that I don't think it's going to get resolved this year. But I do think as states start to break off from these pacts, like you were talking about, Joel, we're gonna crack this problem. So over in Sweden, Joel, Vattenfall has run into a problem because they're going to halt the development of the 1.4 gigawatt Norfolk Boreas offshore project. Uh, Now, this is not so much Vattenfall, but you've seen more and more of these, not just in the United States, but even in Europe, where projects are being installed. There's another one this morning up from Sweden saying they're going to put it on hold. It really comes down to some environmental concerns. In Europe, it's mostly environmental concerns with all the environmental European Union regulations. It seems like everybody's trying to do the best that they can. And some of these projects, even though the developers say they meet all the requirements, the countries are coming in and the oversight, the bureaucracy is saying, hey, you probably do, but it's sort of marginal. We want to hold off. And even Vattenfall has made some changes to the way they're doing projects. So like putting fewer turbines in, but larger turbines to kind of get to the same power output to create less environmental impact for sure. Is still running into difficulty, and this Norfolk Boreas offshore project is one of them. I mean, this Norfolk Boreas project was designed to power around 1.5 million homes, right? And it had won a contract for difference in an auction last year, right? And guaranteeing a minimum price of roughly 37 pounds per megawatt hour in 2012 prices, which is equivalent to about 45 pounds a megawatt hour today, right? So this whole project was going to power the UK. So Vattenfall, which is a Swedish utility, is trying to help out the UK, but the economics aren't working, and everybody's starting to get scared. Again, you can't do that now, right? It takes industry years to get to the point where they're ready to go ahead and do this and get all the financing in place and make these projects happen. Developers are going to go somewhere else.
Yeah, I mean, the UK they've got some offshore wind goals. 50 gigawatts is their goal, right? Up from 14 gigawatts that they have now. Now they are the leaders, or among the leaders in the North Sea. There, of course, of the Danes and the Germans and Dutch and whatnot, and everybody's got some offshore wind there. But they're among the leaders of offshore wind. They're the people that have had it in the longest, and that group of countries. And they still want to charge forward. Now, the problem with the UK is for a long time, or Britain, in a long time, they had a moratorium on onshore wind. They weren't allowed to build onshore wind. So they're building offshore wind, touting this, the green energy transition, all these things. And they, Siemens Gamesa opened up a new factory there in Hull just in the last year, and a lot of things going on there. But then the same thing, right? It's the PPA price. It's a carbon copy of what's going on here, except for instead of getting denied the PPA price, the Vattenfall is just going, well, this is what we're going to get, so screw it, we're not going to build it because it's not going to make money for us. But it's project costs, inflation, interest rates. So it's almost looking to the point of the federal governments may have to step in here and help these guys out if they want to meet their goals. If they want to meet 50 gigawatts of offshore wind, well, in the pure private play here, it doesn't meet that yet. Right? The economics don't work out. So if you want to have it, you may have to
finance it.
Yes, finance, subsidize it somehow. You got to do something, or may have to do something. Like I say, you got to, or you have to, but you may have to do something to hit those goals.
Well, a lot of the operators are reaching out for credit financing right now. You see them getting, you see news articles about how they're trying to restructure, or they're trying to get more financing, more credit available to them. And the reason they're doing that is because inflation. They're doing it because of rising costs, the whole thing. The states are going to have to step in and back that, right? Put a bond behind it. As we talked to Phil Totaro about this, there needs to have some state backing. You can negotiate with an operator on some level. If it provides stability for the operator, they're more likely going to take maybe a little bit tighter crunch on the operating profit if there's more certainty to it, right? You're willing to negotiate that certainty for income on some level.
I mean, we've seen governments step in to bail out industry regularly, right? 2008, 2010 in the US, they jumped in to bail out the car industry. We've bailed out banks. We've bailed out all kinds of people, bailed out airlines, right? So we've done things in the federal governments have bailed out entities in the sake of it's good for the whole country. It's good for the group of people. It's good for our constituents. Well, if you're serious about your energy transition goals, then this is also good for your people as a whole. So maybe there's definitely some play that can happen there. I guess we'll see what happens coming up on election cycle if something does. But
And touching on the labor, U.S. competitiveness, U.S. factory building, boy, when these projects get rejected, Europe or the U.S., doesn't really make any difference. It really puts all those projects in, yeah, why would I build a factory if I'm not sure the developer is actually going to go forward? Right? This is, again, going back to the conversation with Phil Tara, what is that critical, it's the FID, right? If they're not going to make an FID, I'm not going to start putting steel in the ground of my factory. That's just not going to happen. So it is really creating a big problem that Wood Mackenzie's been talking about of can't delay it because you're just not going to be able to do it. If you start delaying it, you need to do it now.
yeah, I mean, GE, we talked about this in an episode not too long ago. GE saying, hey, we'll build a blade factory, we'll build a nacelle factory up on the Hudson, not too far from where you're at. If to fulfill these, or the order book that could be coming from all of these wind farms offshore in the northeast part of the United States, if they don't come, well, there goes those jobs, there goes that investment. It's tough.
It's hundreds of jobs, thousands of jobs locally. It's a big deal. Wind turbine blade damage occurs every day all around the world, and finding knowledgeable engineers to get your blades back in service is a serious problem. And as we know, operating with damaged blades is really, really risky. Well, there is a solution. Meet WinPower Lab, your ultimate partner for blade risk management. WinPower Lab's team specializes in all things blades, from in-factory inspections and root cause analyses to aftermarket product guidance and end-of-warranty campaigns. It's time to get those damaged blades back working for you. Connect with the global blade experts at WinPower Lab by visiting winpowerlab.com. Joel, geothermal is making a comeback in the United States. Fervo Energy, a company developing a quote-unquote next-generation geothermal energy technology, claims that tests have confirmed its commercial viability. Woohoo! The technology uses horizontal geothermal drilling techniques from the oil and gas industry to access previously inaccessible markets for renewable energy. They've been down in Nevada, and they had a 30-day test in Nevada show that the Fervo's system achieved a 63 liter per second flow rate at high temperature, allowing for 3.5 megawatts of power production, setting new records for flow and power output from an enhanced geothermal system. Okay, so Google and a number of others have, I think Bill Gates has invested in this company. And I watched a number of YouTube videos about it. I've been reading up about this for a while. Joe, what they're doing is they're drilling vertically down and then making a 90-degree turn and drilling horizontally. And so they're doing that twice, right? So they got a pressure side and high pressure and low pressure side, essentially. And they're pushing fluid through that connection. So if you drill, maybe Joel, correct me if I'm wrong here. The simple way to do this, you just drill 2 vertical holes, and then it would leach from hole 1 to hole 2. You pressurize 1 and the water will leach over to hole 2 and get warm as it's running through the ground and then come back up as hot water, right? The problem with that, as I understand it, is when you drill those 2 holes, you may not have a lot of flow between the two. You end up with a quote-unquote dry hole. You just don't know.
And there's ways to combat that, but go ahead.
But so what they're doing now is they drill vertically down and they take a right angle and they get 2 parallel holes such that it's easier to control the flow between the two. So you can basically drill a bunch of vertical holes and turn right angles, drill horizontal holes at the end, and get that flow rate consistently and pull more energy out of the earth. That's sounds like where they're headed. Does that make sense to you?
Yeah, absolutely. So I can give a couple minute long geophysics and drilling lesson here. The majority of everything that Fervo is doing and everybody else that is pioneering in the geothermal energy production space is completely 110% piggybacked off of oil and gas drilling techniques, right? even all the way down into the exploration phase. So when you go to an oil field, the first thing you do is you'd say like, okay, brand new oil field, or we believe, by the surface geophysics, this is what could be below us. Well, we'll do a seismic test. So seismic testing basically is like when you take an MRI of your knee, say like you're out riding your horse and you fall off and your knee goes bad. Okay, we got to take an MRI to see what's bad in there. That MRI, they do the study and then they can slice it up, right? They can go like slice, so we can see at what level the inside of it looks like. Well, a seismic basically exploration study of an area will do the same thing. You'll end up with a cube basically of data, and that cube you may have been, when you did your testing on the surface, which includes sending energy down by vibrating or blowing off dynamite and listening with a lot of microphones, when you get all those returns, you can start to develop this picture of the subsurface, right? So you can start to see where things are dense and where they're not so dense, and where there may be a gas pocket or a oil pocket or a water pocket, or if it's a cap rock. A cap rock is something really, like a shale where you can't really get through it. Or shale, I guess you can get through. It's porous, or you may have like sandstone, limestone, granite. These are general things, right? But it looks like a layer cake almost, like if you got a German chocolate cake that had a couple different layers in it. But the frosting layer, will be like the pay zone, right? That one frosting layer that's 10,000 feet below the surface, that may only be 20 feet thick. That's where all the oil is. And so when you drill down, you want to get into that layer. And then you can pump the oil out of that. And when you pressurize that layer, the rock above it and the rock below it create kind of like a fence. And that's what pressurizes. So when you're drilled into there and you pressurize that spot, just the oil or the gas or whatever material you're trying to get out of there will flow from that area, because below it, there may be a cap rock. Above it, there may be a cap rock, and you can't get anything through. So what they're doing here is they're using that exact same technology. And the majority of these geothermal wells are done in areas where they've already been drilling for oil and gas forever. So they have like the company TGS, who we've talked about a bunch of times, getting into offshore, Norwegian company. Their entire business model for the last 40 years has been on well data. So they have a library of this well data of literally, like in the United States, like every well that's ever been drilled, they have the lithography, the layer cake of the whole thing, plus all the seismic data and everything that you can join together. So they have one of the best libraries you could ever imagine for a company that would be going out to do geothermal. They'll go, we want to do geothermal near Dallas, Texas. Okay, we can get onto this lease. What does the data look like? What does their subsurface look like? Everything. They've got all the data already. They can drill down. They know that they need to drill down vertically to 10,612 feet, and they'll do that, and then they'll turn that drill bit 90 degrees, and that's just done by basically centrifugal force, and there's an inertial measurement in the unit, and you can drill it, blah, 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 turn that one sideways, turn this one sideways, and once you...
Wait. How do you get a drill bit to go sideways? I'm trying to understand how they make that magic happen.
So to turn a drill bit sideways, and my buddy Jared Addy, he's a horizontal driller out from Midland. I've sat around, he's in Midland, Texas, and he'll tell you, and he loves Midland. Don't ever talk bad about Midland when Jared Addy is around, because he'll tell you all about it.
I've been to Midland.
Yeah, and I've had some beers with him, and we've talked about how this works. But basically, it's the same concept of like if you're spinning a top, right, and then you put weight on one side of it, it will eventually spin down the table in that direction. So when you have a drill bit and you use centrifugal force to change the direction of the drill bit, and it's surprisingly accurate, where they're getting to they'll drill right along a lease line. Like, so the surface, if you have a 40-acre lot, a parcel, they'll go right down 2 miles down and then turn that drill bit sideways and go right along the property line 2 miles down. It's pretty impressive how accurate they can be. So back to like how the geothermal's working, you get down into that pay zone, so you have the fence above you and the fence below you. So when you start to pressure it up, the water has nowhere to flow but into the pipe. The pipe becomes the least point of resistance, right? Because it doesn't want to just keep going left and right, because, I mean, it can, but if it finds a seam to go into the other pipe, it'll go into that pipe. So if you do that, and then you just think about if you took 2 straws out of your McDonald's cup and then bent them 90 degrees and then put them into the ground and just kind of laid them over the top of each other, and then they're perfed. they're perfed as well. So those pipes, once they drill them, they put explosive charges down in them and then boom, blow them off, and it will put holes in the casing of the pipe. And then so the water can flow into the soil or the rock formation and out of it into the pipe. So you pressure, high pressure, low pressure.
That makes sense to me, right? So you have a perforated pipe, and one side's pressurized, you're running it through the earth, and then the other side is receiving the pressurized water back warmer than when it went in.
That's the crust right there, right? Is that what people don't understand is when oil comes out of the ground, it comes out of the ground, depending on where you are, somewhere between 120 and 140 degrees Fahrenheit. And that's just because that's how hot it is down in the Earth's core down there.
Okay, so let's play this out a little bit. If Fervo is right, they're using oil and gas techniques to basically drill parallel holes and pull up, then let's say 3.5 megawatts of power production. Okay. So let's use Texas. Like West Texas, where a lot of wind turbines are, there's also a ton of oil wells. You'll see wind turbine oil rigs like all over the place. Yeah. So if I'm an operator in Texas and I have a bunch of wind turbines on the top side, why wouldn't I drill a megawatt hole everywhere I could for geothermal?
If I was to do that, I would go to someone who had a lease that is not producing many barrels per day or has dried up. Because what happens is there's a workover rig to it. It's like, so you may have drilled a hole in 1980 and that thing produced well until 1995, and then it's just been slowly. And then in 2005, prices went back up in the market, $1 per barrel. So you went and worked that hole over and then pressurized it again, and you got a bunch more out of the ground. But now you're getting to the point where we've worked that hole over 3-4 times, and it's been in production for 40 years, and we're just not getting that much out of it. And maybe time to retire that asset. Well, that might be time for Fervo Energy to step in, use your hole that is not necessarily a dry hole, but a pseudo dry hole that's not producing what it could be or has been in the past. They'll use that same hole, boom, punch it right down, and now you just got to turn it sideways a little bit, and they've now reduced their costs of setting up the geothermal plant.
Oh yeah, by a factor of 10, that'd be my guess.
And you could drill holes. You could go over a 500-acre area and punch a bunch of these holes in the ground and have one central plant and run it all back to that plant. 3.5 megawatts out of that. I don't think it'd be pretty easy at all, because it's just basically when they bring it to the surface, are they running it through a turbine, like a steam jet turbine?
They're spinning a turbine. That's all. It should be pretty simple, right? So existing wind operations in the right parts of the country could easily add 50%, 100% to the output of that wind farm by putting some geothermal with it.
Yeah, and they could use their existing grid interconnects and existing transformers.
Right. I guess that's why Google and Bill Gates have invested in these things. Jeff Bezos is in, Richard Branson's in. And
here's a couple things too. This is the thing that isn't talked about in this article. This is immediately dispatchable power. That's the big ploy, or not ploy, but the big knock against solar and wind is they're not immediately deployable. They're only deployable when the wind is blowing and the sun is shining, unless you have battery backup, right? So, but even long-term battery storage is not quite there. If this works, or it is working, but if this can be deployed at scale, this is immediately deployable power, just like a gas turbine plant. You just close the valve and open the valve, and you got power.
Right. You got that stability on the grid, which is what Rosemary talks about all the time. Having stability on the grid is key to being with the renewables. You need that stability. Maybe geothermal is going to fill that void. That would be remarkable. Am I way offline here? Just extrapolating out 10 years from now, is Texas full of geothermal wells?
It depends what happens to the $1 per barrel of oil.
Or California, Nevada, Arizona.
Well, here's the other thing too. If you're looking at deploying this technology at scale as quickly as possible, Texas and New Mexico and Oklahoma are the best places to do it. Why? Experienced drillers and drill rigs aplenty. Also, Pennsylvania.
A lot of holes.
Well, the Pennsylvania has a ton of good drill hands. North Dakota, like all these places where the oil field has been plentiful. If this technology is ready to scale, you've got drillers, you've got workover hands, you've got all the equipment, you've got all the people, you're ready to roll.
It's just the energy provided by this one hole, 3.5 megawatts of power production seems really high. I was thinking they begin the 100 kilowatt range, but if they're really in the megawatts, that's impressive.
So let's look at economics again. Here's the economics again, the thing we got to think about. 3.5 megawatts. If that was a 3.5 megawatt wind turbine, that at the megawatt per million per megawatt, that costs $3.5 million to do. You're not drilling deep horizontal wells that cheap. They're expensive to drill.
How much? Well, that would put it in perspective, right? If I can put a 3.5 megawatt machine out there on this piece of property, and it's going to be about $3.5-4 million to get up and running and producing power. What do I match it with in a geothermal? Is it even in the same ballpark? Is it 2x, 3x of a GE wind turbine?
So and with the 3.5 megawatt, we don't know if that's 2 holes. Is it just 2? Is it 5? Is it 7? Is it a spider web? Did they use existing stuff? That's going to be the key. If you can use existing holes, because if you can run down and just clean out a hole rather than drilling a fresh one, oh man, the cost difference is huge.
GE Vernova's onshore wind business is implementing a focus on quality and lean management to improve efficiency and profitability. Two areas that GE has needed to focus on for a little while now. The company is committed to using higher quality components in wind turbines and is encouraging employees to stop the line if they have concerns about quality. Now, that to me is old GE. That's old GE. GE would totally do that, at least the businesses I was involved with. So it's good to see some of that cultural shift back to what GE has made itself famous with. The business aims for zero defects in manufacturing and focuses on high-performing workhorse products to streamline its portfolio. The fleet performance management team, more recently, is looking at sort of components that are failing and stop replacing them with components that fail, right? They know components that have historically had problems. They're saying, look, we're not going to put a bad component chasing a bad component. We're going to stop doing that. We're going to put a better product out there and get rid of some of these quality issues. So the continuous improvement that is being emphasized at GE now daily with a Lead with Quality initiative and meetings is really, they're trying to change that business. Now, more recently, GE Vernova's Vic Abate, who's running the onshore part of that business, is really trying to simplify the operations, improve quality, and also at the same time expand its foreign markets for growth. So this is really good for GE. I think obviously it's painful to go through that process, but it all makes sense, right? It just seems so obvious. Like, get the quality right, the customers will come back.
Yeah, it seems like the GE there for a while. In the last few years, it was kind of like a wild horse off running, like kind of knows what it's supposed to be doing, but it's just running. And now they got Vic Abate sitting in the saddle with his hand on the reins, kind of dialing it back in, like calming it back down and making it go. Like I really like the bullet here in the article about focusing on the high performing workhorse products to streamline its portfolio. Now, we've been following what's been happening at TPI lately. TPI, in one of their articles that I read today, said, our customers are streamlining their portfolios. And that's the same thing it says here, right? We know GE's a big customer. They signed that big deal with TPI not too long ago. So I think what's happening here is we're starting to see this collective voices, right? We've heard it at Vestas. We've heard it at Siemens. Now we're hearing it at GE like, hey, guys, too many different models, too much going on. Let's kind of rein it back in and focus on doing some things well, and then we can move forward. And it sounds like GE's doing it now through this with Vic. TPI was just talking about doing it themselves. Right now, they're a little bit more beholden to what the OEMs are going to do because they're kind of like Phil was telling us, a build to print model. But you heard Vestas talking about it not too long ago, saying like we need to slow down to speed up. And then Siemens, of course, with the things that they've got going on internally, you're going to hear the exact same thing come out of there. We want to dial it back, get things right, and then we can move forward. So it sounds like every OEM, all the major Western OEMs, I should say, I'm not going to say every OEM, the major Western OEMs are all kind of singing the same tune, as they've been singing the tune of, hey, we're not profitable all along. So in the last few years. So some collective changes by by all of the OEMs. It looks good. I think it's good on the industry. It's gonna in a few years when it shakes out. I think this is going to be you said I think last week, Alan. This is an inflection point.
Definitely is. And GE has obviously is pausing some projects, and one of them is out in Wyoming. So the Rock Creek 2 wind project in Wyoming, which is going to have a capacity of 590 megawatts, so it's a pretty big project, will be delayed by a year due to problems with the blade, well, the turbine manufacturer GE. Now, that from things I hear, it has to do with the blades. So they're talking about delaying 30 of the 66 turbines and a portion of the transmission line construction because of this delay that GE has put into their schedule. Pacific Corp, the owner of the wind farm, has submitted notification of change in the construction schedule to the, local people, basically telling them, hey, we're going to be slowed down here. So it looks like GE, which is having problems in a supply chain, particularly with blades, and it sounds like TPI is part of that. They're saying we are not going to deliver, most likely. Joel, you and I talked about this earlier today. Most likely, the blade manufacturer, which most likely is TPI, has already built these blades to go out to Rock Creek 2. It seems like this would be the case, right? The timing seems like it would be this way, that they have built these blades and somebody said, yeah, we're not super confident in these blades. Let's not put bad product after bad product. Let's stop it, get the blades right, and then finish the project.
Yep. I think that's a good move.
That seems like a Vicabate top leadership in GE stepping in and saying, stop the bleeding. What are we doing to ourselves? Yeah, it's painful.
Yeah, don't make another problem for us tomorrow, right? That'll be a problem for a year, 2, 3, 4 years, continuing to see these mounting losses, right? They just released, what was it, 350-ish million in loss last quarter, which is better.
Which is better than last year.
Yeah, better than last year. It's still a staggering number, but hopefully that number continues to trend back towards zero. I know that sounds like a weird thing to say. They see it have a loss trend or a profit trend towards zero, but that would be positive for them. I don't know. I'd love to hear, ideally in a great world, I'd love to hear directly more from Vicabate, right? Like, what are you guys doing to make this change? So I guess that's my Vicabate. Come on the podcast. Come talk to us. Tell us what GE's doing. Tell us what you guys are, what your focus is on these new these new quality meetings and stopping the line. All these things that sound fantastic, that can turn around and have the possibility of turning around GE's profitability, GE Vernova's profitability here. We'd love to hear it.
I think they're making the noise internally at the moment. I think that's where it has to start, and then almost simultaneously, just soon after that, they could be talking to customers about what's happening and why it's going to happen. And if I'm a customer of theirs, I'm not going to be happy about a year delay. Certainly not. But I'm thinking long term here. I am certainly happy they're going to have a better product for the 20 years I'm operating this farm with a slight delay than 20 years of problems.
Happy that the company's still going to be around in 10 years to be able to solve any problems that you do have.
Oh, sure. Right. I think GE can point to Siemens Gamesa at the moment and say, Siemens Gamesa put out a whole bunch of products that are having a problem. Now they're talking about 30% of the blades in certain platforms having problems. GE knows it does not want to be in that situation because it's going to be stand up of his own company at the end of the year. It can't have that. It has to stop those problems from being out in the field. It can't take $1 billion write down. It won't be possible in a year. BP Wind Energy is upgrading its Flat Ridge 1 wind farm in Kansas with new Vestas wind turbines to generate more power efficiently and reliably. The upgrade is expected to provide 20 to 25% gain in energy production across the wind farm. Joel, wow, that's a lot. The project reflects BP's commitment to renewable energy and its goal to become a net zero company by 2050. BP is replacing the 19 decades old units. And I did look this up, Joel. I never forget what kind of turbines they are. Like, oh, they're a Clipper. They're replacing Clipper turbines with new Vestas turbines. So,
oh, really?
Yeah, those are old turbines, right? It's going to be, the guys working at that site are going to be super impressed with those Vestas turbines of all the bells and whistles that come along with the new turbine. But BP is also planning to recycle the fiberglass blades off those Clipper wind turbines, keeping about 1.5 million pounds of fiberglass out of the landfill. So nice job there. So this week, Flat Ridge 1 is our wind farm of the week. Congratulations to BP and everybody at Flat Ridge 1. That's going to do it for this week's Uptime Wind Energy podcast. Thanks for listening. Please give us a 5-star rating on your podcast platform and subscribe in the show notes below to Uptime Tech News, our weekly newsletter. And check out Rosemary's YouTube channel, Engineering with Rosie. And we'll see you here next week on the Uptime Wind Energy podcast.